Algebra, I won't tell you what just took place. I was talking to myself for 20 minutes, not realizing that I had not pushed the record button. This lesson is called Factoring Quadratic Trinomials. We're going to factor primarily two types of quadratic trinomials. Ones whose lead coefficient is 1, so I've got that written here, x squared plus bx plus c. And the others where the lead coefficient's not 1, and I've got that written, ax squared plus bx plus c. For x squared plus bx plus c, we're going to look for two numbers, two integers, positive or negative, whose product, that is what we multiply, will give us this constant labeled c here. And the same two numbers will be added to give us a sum, which will be the linear coefficient, or the number in front of x, labeled b. Let's consider for our example, to learn how to do this, x squared plus 5x plus 6. We're going to ask ourselves, what two numbers have a product? That is, what two numbers can we multiply to get this 6, and yet add those same two numbers and get a sum of 5? Well, the factors of 6 are 1, 2, 3, and 6. We could either pick 1 times 6 or 2 times 3. 1 times 6 is 6, and 2 times 3 is 6. But it's not 1 and 6, because if we add 1 and 6, their sum is 7. We're not looking for a 7. But if we consider the other two factors, 2 and 3, 2 times 3 do give us the product 6, and do give us the sum. That is, we add them together and we do get the 5. That's what we want. So that turns out to give us x squared plus 5x plus 6 will equal, we've got an x here and an x here, because x times x is x squared. X times 2 is 2x. Then 3 times x is 3x. And if we add the 2x to the 3x, lo and behold, we get the 5x. Those are our like terms. And then 3 times 2 gives us the constant 6. So what we do is, after we set up the two factors, we want to check by doing the distributive property mentally, just to make sure that we end up with what it is we're supposed to have, x squared plus 5x plus 6. Okay? In general, you must be able to multiply and add mentally to be successful at this lesson. You must be able to multiply and add mentally. Another example, let's factor x squared plus 12x minus 3. We know 1 times negative 13 is negative 13. We also know negative 1 times 13 is negative 13. And 13's prime, so it's either going to be positive 1, negative 13, or negative 1, 13. Because either of the two products give me negative 13. The pair we pick are the ones whose sum gives 12. So if we check from these two, 1 plus negative 13 is negative 12, while negative 1 plus 13 is positive 12. That's what we want. We want the positive 12. So x squared plus 12x minus 13 equals, again, x times x gives the x squared. Now that we know which two we want the 13 positive, we want the 1 negative, and again we check. X times x is x squared. X times negative 1 is negative 1x. 13 times x is 13x, and if we add the 13x with the negative 1x, we get the positive 12x. It's all good. Now we're going to get into something that's a little bit busier. That is for lead coefficient, not 1. And it might get a little bit more involved, but we can handle it. Let's factor 4x squared minus 4x minus 3. Now I'm going to set tables, because it just helps to keep things a little bit more organized. For the lead coefficient, I put the number 4 at the top of a table, and then for the constant negative 3, I set it at the top of a table. Below the table, I put all the groups of factors that can be multiplied to give me the number that I'm looking to use on top of the table. I don't always exhaust the tables by putting every pair of numbers that will go there. If the numbers are small enough for prime, I probably go ahead and do it. But if the numbers get a little bit larger, say 24, say 144, I might not list every pair of factors, because it might become more difficult to compare the two groups to see what I'm looking for. What I'm looking to end up with by way of using these two tables is I want to somehow figure out how I'm using them to come up with this -4 right here. I will now show you. First of all, 1 times 4 is 4, 4 times 1 is 4, 2 times 2 is 4. That's the 4. -1 times 3, 1 times -3, 3 times -1, -1 times 3. They're all -3. And that's where that came from. Now, how to use the numbers in these two tables to look for the correct pair of numbers. The first example, I would take 1 by way of the distributive property and multiply it by the 3 right here. 1 times 3 is 3, and then correspondingly 4 times -1 is -4. But if I add the 3 I get from multiplying 1 and 3 to the -4 I get by multiplying 4 and -1, -4 plus 3 is -1. I'm not looking for -1, I'm looking for -4. I could retain this ordered pair and go through doing the like work for the other rows or other pairs of numbers in this table. But I went ahead and found the correct pair from each table, and let me show you how I knew it was the correct pair. 2 times -3 is -6. 2 times 1 is 2. The -6 from 2 times -3 added to the 2 from 2 times 1. -6 plus 2, that's -4. That's what I'm looking for. Once I have the two pair I want to use, I circle them because I might get distracted doing something else. So when I come back, I don't want to have to start this all over. So I take the original quadratic trinomial, 4x squared minus 4x minus 3, set it equal to, set up two sets of parentheses. This 2 will be the first 2 in front of x. This 2 will be the first 2 in front of x in the second binomial. This -3 will go first in the first set of parentheses as the constant here, and the 1 will go last as the final constant in the second binomial here. If this is correct, I should be able to distribute these two, combine the like terms, and come back to the original quadratic. 2x times 2x is 4x squared. 2x times 1 is 2x. -3 times 2x is -6x. When I add my positive 2x to my -6x, I get -4x. And then last, -3 times 1 is -3. So that's it. That's correct. The other answer you could have come up with, depending upon which pair of numbers you picked, you could have ended up with 2x plus 1 times 2x minus 3. That's just the commutative property between these two binomials. But that's it. And that's how we do it. You need to do a lot of examples to get comfortable with this. And remember, you've got to be able to multiply and add mentally to be successful. See you in class next week. Have a good weekend.